If you printed off the note sheet, I'm on the back side now. I'm going to do a few more examples with you. So on this one, my turning point is going to be at x is -1. So I know that this place right here, there's going to be some kind of graph over here and some kind of graph over here. So when I make my table of values, I'm going to have x less than -1. And then I'm going to have a table of values for when x is greater than or equal to -1. So this one is going to use this equation because that's where x is less than -1. So I'm going to do -1 and then some numbers less than -1 like -2 and -3. And then I'm going to go plug these numbers in for x. -1 plus 2 is 1. -2 plus 2 is 0. -3 plus 2 is -1. So I'm going to graph them. -1, 1. Now, at this place, notice there was no bar, so this is going to have an open circle here. And then -2, 0, and -3, -1. So it's going to go away from the line, the divider line. Okay, I'm going to try -1 and some numbers bigger than -1, like 0 and 1. 3 times -1 is -3, plus 1 is -2. If I put in 0, I get 1, and if I put in 1, I get 4. So I'm at -1, -2, and that one's going to be a closed circle because it's got a bar underneath it. 0, 1, and 1, 4. It kind of looks something like this. Notice on each side of the line x equals -1, the graph goes away from that line. Let's do the next one. I'm going to have a table of values for each one. I'm going to have a table of values for when x is greater than or equal to 3. And I'm going to have a table of values for when x is smaller than 3. And since this one doesn't have a line underneath it, I'm going to circle it because I know that's got to be an open circle. So here I'm going to do 3, 4, and 5. Here I'm going to do 3, 2, and 1, and know that has to have an open circle by it. Notice on this one, where x is greater than 3, there isn't any x. So what it's saying is for every value I put in for x, the y value is always going to be 3. So the y value here is always 3. So if I graph that, there's 3, 3, 4, 3, and 5, 3. So that one looks something like this. It's a horizontal line going through y equals 3. The next one is a little different. So I'm going to go put 3 into the equation, so I get 3. That means at 3, 3 there's an open circle, but there's already a closed circle there, so I don't need to change it. If I go put 2 in for x, I just get 2. If I put 1 in for x, I get 1. So I have the point 2, 2, and 1, 1. So as I move away from that divider line, that line looks like this. This one looks different. As you'll see, it's got 3 equations. So that means I'm going to have 3 parts to this graph. I'm going to have a part for when x is less than or equal to -2. I'm going to have a part when it's between -2 and +2. And then I'm going to have another part where x is greater than 2. So here, I'm going to have -2 and some numbers less than -2. Here I'm going to have -2 and 2 and something in between. I'm just going to try 0. And here I have 2 and numbers bigger than 2. Notice this has an open circle and this one has an open circle. So unless there's already a closed dot there, I'm going to put an open circle. So when x is less than or equal to -2, I'm going to use in this equation. So I have -2 plus 5, which is 3, -3 plus 5, which is 2, and -4 plus 5, which is 1. So my graph is at -2, 3, -3, 2, and -4, 1. And I would be moving away from this line, so the graph's going to go like this. In the next section, I'm going to put -2 in here. So negative 2 times negative 2 is 4. 4 minus 1 is 3. So at negative 2, I'm at 3. I've already got a point there, so I'm good. Try 0. Negative 2 times 0 is 0. 0 minus 1, negative 1. And then 2, be negative 4 minus 1, which is negative 5. So I've got a point at 2, negative 5. And that one has a closed circle here, so it kind of looks something like this. The last one, I put 2 in, so I get negative 5, negative 3, and negative 1. So 2, I'm at negative 5, I already have a point there. At 3, negative 3, and at 4, negative 1. So each part of that graph is different based on the domain, based on what I put in for x. If I put anything smaller than negative 2 in, I have this function. Anything between negative 2 and 2, I have this function. And anything 2 and beyond, I have this function. Notice this still passes the vertical line test. The last example of graphing from given a piecewise function looks a little different. If you'll notice here, there's no x's. So it doesn't matter what I put in for x, I'm going to still just get y equals 4, y equals 5, y equals 6. So if we think about this one like setting up a table, this would be 0 to 2. This would be 2 to 4. And this one would be 4 to 6. So when I try numbers between 0 and 2, I'm always going to get 4. When I try numbers between 2 and 4, I'm always going to get 5. And when I try numbers between 4 and 6, I'm always going to get 6. So when I put in 0, I get 4. That's a closed circle because of this line. 1, I get 4. And 2, I get 4, but that's an open circle. Here, between 2 and 4, when I try 2, I get 5. And that's a closed circle. When I try 3, I get 5. And when I try 4, I get 5. But notice there is an open circle there. The last one goes between 4 and 6. That'd be closed circle, closed circle, closed circle. Actually, this last one is an open circle. So this one is called a step function. And someplace you can see why it would be called a step function. It looks like you're going up steps. A place where you might see this is if you ordered something online, they might have a price. So if an item weighs between 0 and 2 pounds, you pay $4 for shipping. If an item is between 2 and 4 pounds, including 2 pounds, you pay $5. And if an item is between 4 and 6 pounds, you pay $6. So there's no in-between cost. It's not a constant rate of change. It's just intervals on how you would step up for pricing.